I know this is last presentation, but I will try to make it fast and best. I think I am the youngest presenter of this conference, and this is the very first conference for me. So, thanks to Aqua Foundation and my organization also. I am Girija. I have just completed my master's, and now I am working with MWH Global in Pune. Today I am going to present my master's project on modeling evapotranspiration using geodetic programming. So the presentation flow will be introduction, evapotranspiration parameters, measurement, alternative approach, geodetic programming, study area, model formulation, assessment, result, and conclusion. So I think since childhood we are aware about the concept of evapotranspiration. But if you look at this evapotranspiration through engineering point of view, then it is really complex and non-linear process. It is simply the combination of evaporation and transpiration, but it is not that simple. There are parameters like solar radiation, temperature, wind speed, humidity, which play a vital role for the evapotranspiration process. There are also n number of conventional methods to measure the evapotranspiration, like energy balance, soil-water balance, covariance towers are also there, lesimeter. There are n number of empirical methods. Then there is pan evaporation also. Few empirical methods are Penman equation, Hammond equation, Hargreaves, Thornwhite, radiation, then Turk method. Even though we are having such n number of conventional process or methods, but there is still need of an alternative approach. Why? Because if you look at the parameters like sensible heat, subsurface flow, deep percolation, capillary, then temperature gradient, these are the parameters which are very complex to measure. And also, the short duration measurement of this parameter are not really helpful to calculate the evapotranspiration. Also, few of the methods are giving the evapotranspiration on weekly basis or yearly basis or decadely basis. Those are not giving the evapotranspiration on a daily basis. If you look at the lesimeter, it is very difficult and expensive to construct also and maintain also. Empirical methods, as I said, if you look at the empirical equation, there are n number of parameters in that equation we need to measure. So those are very data intensive methods. Even pan evaporation is very hard to place and maintain also. So nowadays, geodetic programming, which is a soft computing tool, like nowadays we are using in civil engineering. So I use in this project. So it is invented by Kramer and developed by Koza. This geodetic programming just follows the Darwin principle of survival of fitness. The main plus point of this geodetic programming is like the output of this geodetic programming is either program or equation, so that it is most suitable to determine the input-output interdependency. This is a simple flow chart how the geodetic programming operates. So the objective of the study was to develop the mathematical model to estimate evapotranspiration using empirical equations and the geodetic programming. And just it was just a comparative study. So the comparing the result of geodetic programming and empirical equation. So I used the 3 stations at Florida. I got the data over a period of 2000 to 2004, that is 4-year period. And in that period, I got the evapotranspiration measured on daily basis by using covariance tower and other subparameters like net radiation, humidity, temperature, and wind speed. Using this data, I formulated 4 models. I used 3 empirical methods, Penman equation, Hargreaves, and Hammond equation. For geodetic programming, while creating the model, I think I thought about the limitation of conventional process. That is, it requires n number of parameters to get the evapotranspiration. So I thought, like, if we limit, or like if we have the limited number of input, then can we still calculate the evapotranspiration using the geodetic programming? So to check the interdependency of input and output, I just try out a correlation factor and identify the correlation of input and output. So from this table, if you come, you can get that for the net radiation, the correlation is the highest. So you are getting the number near to 1. So like that, I created 4 model with the increasing number of input. And if you look at the R column, you will come to know that like even though the number of input is less, then still the R value for the input and output, it is closer. So we can calculate evapotranspiration with a limited number of input also. But still for this study, I use 4th model, which is having all components, all inputs. So for all 3 stations, I get the equation from genetic programming. Right now, this is not in a good statistical format. I need to improve these equations. After getting all the 4 equations and result, I compare these results using not just 4. I use 8 error measurements. So I'm showing this for the showing the result for only 1 station. So I get the error values like this for all model and for 8 errors. But this is not the result, or this is not the end. I then again still categorize this error value. For example, for R value, I categorize R value in, from excellent to bad, and I provide number from 4 to 0. So assign some values. Okay. Then after like categorizing each error, then I use the new technique, or like I can say the new invention of evaluation index. So evaluation index is just an average of all error values, or like say A values. So if you look at this table, you will come to know that for the first error, okay, from this range from 0 to 4, I get 4 for first A1 for Penman equation method. So like that, I got the average, that is evaluation index for each error and each model. But this is not again the end. Then I again classified this evaluation index value into the category of poor to excellent. So if the I value is within 3 to 4, then it is A class or excellent category. So if you look at this table, then you will get an idea. The I value for Penman equation is 3.5 and genetic programming is 3.75. So those are close values. So I can say like genetic programming is working good. Even I compare for station 2 and 3 also, I got the same result. For both other stations, genetic programming was the only perfect assessment. Actually, the conclusion of the study is very simple, like genetic programming is working well. There are having few limitations also, but I will say this is not the end, and this is not the end of my research. There is still future. So I can, the genetic programming tool can be used for forecasting also. Right now I use the Florida station and Florida data, but we can explore this tool into India also. And the most important feature of this, like I can generate the real-time control tool for farmer of India, because he is the person who is really required to understand what is the impact of evapotranspiration on his crop rather than engineer. So thank you.